The hierarchy of different sedimentary cycles and their approximate duration can be presented in this diagram. When we say the second order cycle is of 10 to 100 million years and is shown by this blue curve, ups and down cyclicity in sedimentation. Now, the second order cycle can be looked in more detail as is shown by the red curve showing lot of local ups and downs. In that case, the third order is of 1 to 10 million years. The third order's duration is obviously less than that of the second order. Now, let us take this red curve out and we are trying to see the more detail shown by this green curve. There are more ups and downs locally found. Now, this is our fourth order or the higher order. These are the sedimentary cycles. This figure is a summary of relative sea level rise and several terms. Some of these terms already have been explained, but here is a compilation from 3 authors. Onset of forced regression, end of forced regression, end of regression, end of transgression, onset of forced regression. The onset of forced regression is comparable with the basal surface of forced regression. End of forced regression can be linked with the correlative conformity. End of regression is the maximum regressive surface. End of transgression is the maximum flooding surface. Onset of forced regression is linked with the basal surface of forced regression. In this column are the events and in this column are the surfaces which can be found within the rock record. They can be traced. This is a similar compilation with the same author. Onset of forced regression can be called as correlative conformity, whereas in the previous case onset of forced regression in a different language was said as basal surface of forced regression. Similarly, what was earlier said as onset of forced regression as the basal surface of forced regression has been identified as the correlative conformity. So, here the term correlative conformity has come 3 times, whereas here correlative conformity came only once. As in the previous case, this column is for events and this column is for the rock surfaces. We can look at a few definitions: normal regressive, forced regressive, transgressive. Normal regression, it is a progression driven by sediment supply. Sedimentation rate is more than the rate of base level rise at the coastline. This leads to progression with aggradation. Forced regression, propagation driven by base level fall. The coastline is forced to regress irrespective of the sediment supply. Whether the sediment supply is high or low does not matter, but the sea level keeps falling. It is a progression with downstepping. Transgression, it is a retrogradation or backstepping driven by base level rise. Here this was the SL and that SL has moved up and a transgression has taken place. Retrogradation happens. In this case, the rates of base level rise outpace the sedimentation rate in the coastline and it leads to retrogradation. More and more sediments are piled towards the land direction. This is the land side, this is the ocean side. In case of progression with downstepping, when I was telling here, that has to be added. When the forced regression happens, these portions get exposed and that is why subaerial unconformity develops and new deposition goes in this direction. That is why we say it is a progression with downstepping. We are going to see how the stratal stacking patterns of low stand and high stand normal regressions affect the coastal geometry. In both cases, progression is driven by sediment supply. This is the landward side, this is the ocean side. In case of a low stand normal regression, accelerating base level rise, it produces a change in depositional trend from dominantly progressional to dominantly aggradational and it leads to concave up shoreline trajectory. This red dot line shows concave up shoreline trajectory. In contrast, the high stand normal regression characterized by decelerating base level rise. Base level is rising, but it gets decelerated. It records a change from aggradation to progradation, convex up shoreline trajectory. This red dot line shows convex up shoreline trajectory. In this way, the two types of regression are stated. Consider this portion is a solid rock, this portion is sediment, and this portion is sea water. Then a few terms are to be clearly understood. The contact between sediment at the bottom and the water at the top is the sediment water interface. When we say relative sea level in sequence stratigraphy, we mean the depth from here up to there, that means from water level up to the hard rock. When we say water depth, naturally we mean this much depth from the water level up to the sediment, which is again shown here. In the sea, depending on the sediment's accumulation, the water depth can vary. When we say there is an uplift, we mean that this portion is getting uplifted, and when we say subsidence, we mean this rock material is getting subsided. This line marking the sediment at the top and the hard rock at the bottom is called the local datum, and naturally the top water layer is called the sea surface. There is a fixed datum, that is the center of the earth we are considering, that is fixed, and when we say eustatic sea level, we can mean this much of distance. So, eustatic sea level rise or fall will mean change in this distance. We are now going to see glaucony and glauconites, these two terms. Granular form of green pigment was defined as glaucony, and it was defined as a facies, that means an association of green pigment and other minerals. The granular facies of glaucony is a result of glauconitization of granular substrate. Two components of glaucony can be referred. One is the substrate minerals, calcite, aragonite, micas, all clay minerals and quartz, and maybe few other minerals, and orthogenic minerals, smectite component and the micaceous component. The pressure for glauconigenesis is 10 to 30 bar, which is 100 to 300 meter of water depth on an average, which indicates we are dealing with a shallow marine environment. Potassium argon dating can be done on glauconies, and for that reason glauconies are important. Now we are going to see the term glauconites. The term is used to refer dark green minerals found commonly in the marine sediments. In the correct usage, it is a potassium rich mica, that is orthogenic. So what is glauconite? It is a potassium rich orthogenic green mica. It is found commonly in the marine sediments. The other silicates are detritus, and this is the main point of difference. It is orthogenic. Glauconite is orthogenic. Glauconite can develop on substrates such as foram tests, other carbonate fragments, pellets, and lithic fragments. They typically develop at the interface between oxidizing seawater and slightly reducing interstitial water, which means 50 to 500 meter depth. Now we see here from author to author the depth range for glauconites and that for glaucony are different. However, there is also an overlapping depth range. We are continuing on glauconites. They are the reliable indicators of shallow marine environment, but be careful, there can be reworked grains. So if the grains are reworked, broken grains, and then transported to a greater depth, then these reworked grains do not indicate shallow marine environment. They are most abundant in shallow depth in the shelf area in a place of slow sedimentation, and they are found in condensed section. What is a condensed section? It is a section of sedimentary deposit where for a very long time very little sedimentation has happened. How slow can be the sedimentation? It can be less than 1 meter in more than 100 kilo year. What are the other minerals that can occur along with glauconites indicating condensed section? The answer is phosphorites, rocks with 15% or more P2O5 in bulk composition. So in the condensed section we can get glauconites and phosphorites. In the sequence stratigraphic framework, if a very slow rate of sedimentation has happened at some part, then the condensed section can be produced, and this can be the place of finding out glauconites and phosphorites. In fact, based on that, the condensed section can be worked out. As in glauconites, glaucony also traditionally has been regarded as an indicator of slow sedimentation rate, and it is one of the most reliable stratigraphic markers within the marine environment. Just like condensed section, another term can be seen, mega condensed section. This can be a place where more than 50% of highly evolved glaucony can be found. The condensed horizons represent basin-wide stratigraphic markers that may either bracket the TST or HST boundary. Here the condensed section, and here is the HST, and here is the TST. So, the HST-TST boundary can be marked by very slow rate of sedimentation. The mega condensed sections are probably correlative on a global scale. The glaucony can be found in both ancient and recent marine deposits, commonly found in the transgressive sediments. Why the glauconitic minerals are very important? Because they account for 40% of the absolute age database of the geological time scale over the last 250 million years. Like the potassium argon dating, 40 AR, 39 AR dating is also performed on the glauconites. Overall, glaucony can be considered as a depositional facies. It is of sand-sized green glauconitic grains irrespective of their mineralogic structure. When we say glaucony, we do not specify the mineralogic structure, but when we say glauconites, we are specifying the minerals. The color of glaucony depends on the K2O percentage. When it is 2% to 4%, the color is pale to light green, whereas evolved glaucony, that means K2O with 6 to 8%, and highly evolved, that means K2O more than 8%, green to dark green color is found. So, when the color is dark green, K2O percentage is high, and when the colors are light green, K2O percentage is less. So, visually one can understand about the K2O percentage just noting the colors. Glaucony occurs primarily in the transgressive systems tract. Glaucony is less common in the high stand systems tract than in the underlying TST. So, in TST and in the TST HST boundary, glaucony is found rarely in the upper HST. So, these are the locations of slow rate of sedimentation. Present day glaucony forming in outer shelf environments worldwide provides a good modern analog to understand glauconitization along simple omission surfaces. As already told, glaucony is widespread in the geological record